So the first presentation of the day, which is also the keynote for today, is given by Stephen Xuereb, Managing Director of Kiwa PI Berlin. Stephen will talk about testing quality and reliability procedures of solar modules. Stephen, the floor is yours.
Great. Thank you very much for the invitation. It's really a pleasure to be taking part in this event with TaiyangNews. Let's go ahead and share my screen. And put that into presentation modus. Okay. So as mentioned, the topic of my presentation is about testing quality and reliability procedures for solar modules. So I'll just give a very brief one slide about who we are. For those of you that don't know Kiwa PI Berlin, I'll define our module QA approach and then get into two main components of that QA approach in terms of pre-shipment inspection and production module testing, where I'll be giving some guidance and best practices. So Kiwa PI Berlin, we are a technical advisor for PV equipment and PV plants. For PV equipment, we've done over 1,000 factory audits for modules, inverters, battery storage systems, and electrical equipment. We've overlooked over 175 gigawatts worth of equipment produced. And we have testing laboratories for modules in Berlin, Germany, in Suzhou, China, and as part of the Kiwa family with PVAL in California. We joined the Kiwa group in 2022, and you can see here some of the locations that we are throughout North America, Europe, and Asia. So I'd like to start in terms of defining our module quality assurance approach. I think for many kind of experienced buyers and investors in the module market, this process is quite familiar for you. But as was mentioned, in this era of low-cost modules and many more module manufacturers, it's maybe good to have a bit of a refresher course on this. So it's really broken down into four major phases. The first one is during the procurement phase. So properly defining the product, the actual module that you are looking to buy in terms of the technology, size, and other specifications that you're looking for, and really checking to see that that module type from the manufacturer's proposals, that they've actually gone through some kind of qualification program, so testing beyond the standards. And that's something that PVAL will discuss later on today. And then, of course, it's about defining the manufacturing requirements and quality requirements when that product is going to be produced. And all of this should be bound into the module supply agreement, which is key for defining the scope of that quality assurance and the pass-fail criteria and recommendations in terms of how to proceed if any kind of batch or product is to be rejected. So once that module supply agreement is closed and the product has been specified, we move into the pre-production phase. And that's where our risk assessment factory audit is conducted. We typically do this 4 to 6 weeks in advance of production start, going through all the processes and standard operating procedures within the factory in terms of all the various steps of production for modules. And that would give then enough time that once the findings are identified for the manufacturer to actually go ahead and correct those findings before production begin. And this period can also be used if there hasn't been any type of extended reliability testing done, that samples of the modules with the specific bill of materials can already be tested in that phase before production begins. Once the factory is ready and has been accepted, then we move into the production phase. And here's where we do production oversight, so looking over the shoulder during the shift of everyday production. And then there are 3 items that I'm going to speak about in much more detail regarding pre-shipment inspection, pre-shipment testing, so batch lab testing, and ongoing reliability monitoring. And then as part of the final step of batch approval, there's the container loading inspection once the pallets are ready and packaged and put into the container for shipment. And then once the modules are on their way, the final phase is the post-shipment inspections. So once pallets arrive on site, to do a visual and electroluminescence check to make sure that there hasn't been any transportation damage. And then once the modules are installed, to do a final check to see if there's been any damage made during installation. And that includes, visual, electrical, and sometimes also infrared thermography. And with that, you have a comprehensive quality assurance process for your modules. And so, as I mentioned, I'd like to focus first of all on the pre-shipment inspection guidance. So, what's pre-shipment inspection? This is typically an inspection that's done at the end of the production line and at the end of a batch production, where we're typically doing re-inspections or retesting of modules to verify that the factory is meeting the agreed inspection criteria in terms of quality. And these are able to be done in a fairly quick process, so within half a day to a day. And it includes flash testing, so repeating of the flash test procedure to see that the modules are above label. For bifacial modules, doing a sample on rear power testing, and then visual inspection and electroluminescence criteria, which I'm sure many of you are already familiar with. Here is a sample picture of an EL image showing a module with a few cell cracks. And then here's a sample of visual criteria, for example, cable damage, which could be critical, cell damage with misaligned bus wires that could be major, and some frame adhesive residue that could be an example of a minor defect. So in terms of why we do this pre-shipment inspection, let's remember that the module manufacturers themselves also do this type of testing at the end when a module comes to the end of the production line. And what we're doing here is a repeat of those tests. But as you can see here, we've looked at over 774 batches of modules in the last 2 years, and found that really only 10% had no defects. So they are getting through the manufacturer's quality control also with defects, although they still might be in the allowable number of defects. But you certainly do see defects still coming through. And this is for different manufacturers, different factories, and also different module types and technologies. And it's based on the pass-fail criteria that's in the module supply agreement between the buyer and the manufacturer. And on the right-hand side there on the chart, you can see that the largest amount of defects, so around 25% of the defects found, were in the EL category. So that includes multiple types of defects like cracks, soldering effects, which we see more and more of these days, contamination and short circuit cells. Frame defects could be things like damage to the frame, sealant missing, residue shown, or the like, and then followed up by cell defects and cell connector defects. And here we just wanted to show some examples of the levels of defects when you look at the different factories that we've taken a look at. So on the left-hand side, that's a number of different factories from various manufacturers, and we have rates of defects up to 14%, although the average is somewhere between 1% and 6%. And on the right-hand side, for the same manufacturer with the same module type and bill of materials, at different factories, and these might be across one country or across different countries in different regions, you can see that there's variability even within the same manufacturer and the same module type. And that can be due to many reasons. For example, training of the personnel on site, a different type of equipment, maybe equipment that's undergone some kind of maintenance. It could be differences in the SOPs that are used there. And also could be due to the pressure in that particular site, which may be under certain pressure due to resource constraints. So we often get asked for our guidance in terms of, pre-shipment inspection, and is now a pretty standard test being done as quality assurance by the buyer. And so many customers come to us looking for guidance. And the first thing is looking at the sample size. So we refer to the ISO 2859, and there we're looking at general inspection level 2 as our standard level, or general inspection level 1. So for a typical batch size, which we usually push for, is around 10 megawatts. So you don't want to be too large, because then the risk of rejection becomes even greater, and not too small, because then it gets costly and takes a lot of time as well if the batches are defined too small. And so general inspection level 2 usually means 315 modules that are tested, and level 1 being 125 modules. And then looking at the different allowable quality limits, I think it's standard in the industry that no critical defects are allowed. And then for major defects, we're looking at 1.5, and for minor defects, looking at 4.0. And just to look at kind of the benchmarking, how we arrived at those numbers. Well, for the AQLs, looked at a number of different module supply agreements in recent times, so almost 60 different contracts involving 25 manufacturers. And there we saw the following. So the sample size, as I mentioned, 125 is general inspection level 1, is about 75% of the contracts had that as the sampling size. And for sampling level 2 was at 10%. So between 1 and 2, so that, and 200 is for a different inspection level. But for almost 95% of the projects, between 125 and 315 modules were tested. And then looking at the categories in terms of minor, major, and critical. So all the agreements had critical defects as 0. Major defects, half of the agreements had the recommended 1.5, while another 17% had 2.5. And minor defects, 80% of them had 4. So you can see there, when you're looking to negotiate with module manufacturers, you can see that these are the typical levels, and they're not really out of the ordinary. Now, in terms of doing another level of quality assurance during production, so on the one hand, doing the pre-shipment inspection, which is really the first level of quality assurance. A second level is doing additional module testing in a laboratory, either independent of the factory or within the factory itself. And why do we do this? Well, projects are just getting even larger and larger. While we do recommend this also for smaller projects already, from 10 megawatts or so, we do have projects even in Europe now, but clearly North America and Asia as well, of over 200 megawatts of modules being produced at one time, which for a standard size of around 570 watts would mean over 350,000 modules that are produced. And so you can imagine that even if there are specific bill of materials used, 1, 2, or 3 BOMs defined for a specific project, there still can be variations during production. And these could be due to lamination temperature changes, the soldering time variations on the stringer, humidity variations in the curing room for lamination, and then resulting in small bubbles in the glass, or inconsistencies in the cell batch. So even if it's one cell supplier, there still could be even inconsistencies there in the delivery, and electrical connection variations. So what we're really trying to do with this additional lab testing is to monitor a consistent process of materials during the production to minimize risks. And so what we've come up with is 2 levels of laboratory testing that can be done during production and during different stages of production. So one is for every batch, or at a batch level, and a second one is an ongoing reliability monitoring. And the idea here is to do various types of stress tests to check the material and the process consistency. And these tests can be very short in duration to mid-level duration. So there's not the long extended reliability tests that Pivel will discuss a little bit later on, but something in between. And they're really trying to validate the buyer's manufactured models, that they reach the performance in the buyer's contract. And so first we'll start off with the batch testing, or we call pre-shipment testing. And this is done in a way that can be done as part of the batch approval process. And this, as mentioned, can be done either at a third-party lab, as for example, ours in Suzhou, China, which is very close to where a lot of module manufacturers are located, or using an on-site accredited laboratory within the manufacturer's facility. And these tests are designed in a way to check the performance and reliability of models within a relative short period of time. So between 7 and 10 days, this test sequence can be completed, and therefore it can be as part of the batch approval process. You can see here we do an initial characterization consisting of flash testing, EL, visual inspection, and wet leakage testing, and then move into the specific module tests of light-induced degradation, LETID, which we more recommend for PERC cell technology, PID, which we're still recommending for all types of module technology. Something that we've added recently due to the quality issues we've seen with glass modules and the thinner glass thicknesses and larger format modules is adding static mechanical load and dynamic mechanical load tests, and then more standard tests like low light performance, gel content, and peel strength. And for these, we're typically taking a sample of 10 to 16 modules, depending on the test sequence is selected. And we're looking to use the criteria that you see here in the table that we put as kind of the benchmarking that we've seen based on our experience and based on the projects that we've been involved in. And again, passing this level of criteria is part of the batch approval process. So first step is usually before doing any kind of rejection, doing a root cause analysis to see if it was really just a one-off or if there was a systematic quality issue with the modules. And if there is a systematic issue, then it could lead to batch rejection and replacement. The second level, and this is really looking at raising the bar of quality control during production, is an ongoing reliability monitoring. And this is a sequence of tests that is really designed to check the consistent performance and reliability models during a large production volume. For example, for 200 megawatts, that can take over a month to 2 months of production. And it's basically based on the IC 61205 standard. And you can see here that as well as, let's say standard tests like thermal cycling and damp heat, we're also looking, and humidity freeze as well, that is part of the certification process. We're looking also to extend UV initial degradation, for example, which I think will be a topic over the next couple of days, that we know TOPCon cells have been proven to be sensitive to UV degradation. And even though the modules have been qualified initially so that you're buying cells that are UV insensitive, there still could be variations during the production of cells over such a long period of time that could lead to some deficiencies under UV exposure. So it's certainly recommended. And then there are also certain regions that are much more prone to hail. And again, based on the larger format modules and thinner glass, we are certainly recommending doing additional hail tests. And then also, we have a number of clients that are very much interested in making sure that there's pan file and angle of incidence verifications being done throughout the process. So for these tests, we're using stricter criteria than is typically seen in the IEC standards. And this is based on really benchmarking that we've seen throughout our testing and the testing together with PVAL that will be discussed later in more detail. And again, this would, because these kind of tests take much longer, so we're looking at just over, let's say 4 to 6 weeks to conduct these tests. It wouldn't be part of the batch rejection process, but certainly getting information through a root cause and analysis will help inform how the production continues and could potentially lead also to some kind of, financial compensation and agreement with the module manufacturer based on the results. So what I've introduced to you here today, we released recently in our white paper called Raising the Bar, which you can find at the link there below. And the idea here is really raising the bar of quality assurance in this time of modules being overproduced, new technologies, rock bottom prices. We really think it's time to, again, take a closer look at each buyer's and investor's quality assurance procedures. So in summary, The comprehensive quality assurance approach is crucial to ensuring long-term reliability of modules, and really that takes it from the procurement phase to the factory and then all the way to the field. And pre-shipment inspections are important to verify the factory is meeting the agreed inspection criteria and is done before each batch leaves the factory. And production module testing or stress tests for verifying material and process consistency. And the shorter and midterm duration gives you the opportunity to test these at various times throughout the production of your modules for your project. That's it from my side. I'm looking forward to your questions, and if not now, then later on in the panel discussion.
Yeah. Thanks, Steven. I think you really finished in 20 minutes. So unfortunately, we do not have time for questions. I think we can talk a little bit some of the questions I have in the panel, but please stay till the panel. And already there are a few questions in the chat window. It would be really great if you can answer these questions in the chat while I move on to the next presentation.
Yep. So maybe the first one in terms of cell technology defects.
Steven, can you reply in the chat? I'll move on to the next presentation.
Okay. Sorry. Sure. No problem. I'll do that. Okay.
Okay, great. Thanks.
Thank you.